This question isn't actually about chemistry, really. This question's about how practicals are conducted, how you keep them fair, what variables are, and how you analyse your results. So, a student investigated the temperature increase when magnesium powder was added to copper sulfate solution. Now, as I said, it doesn't matter what chemicals they're adding. This isn't a chemistry question. So, as far as I'm concerned, they're adding chemical 1 to chemical 2. It doesn't matter what those chemicals are. We're given a method. Remember, when we're given any information, we've got to read it carefully. It's normally clues and hints towards the answers. So the diagram below shows the apparatus used. We've got magnesium powder in the bottom, copper sulfate solution seems to be the liquid, in a glass beaker, and that must be our thermometer since we're measuring temperature change. This is the method used. Add copper sulfate solution to a beaker. Now my first question is, how much? If I was following this method, I'd be thinking, well, why haven't they told me how much? The only reason they wouldn't tell me how much is because it might come into a question later where I've got to notice that. Measure the initial temperature of the copper sulfate solution. Add 0.1 grams of magnesium powder. Stir the mixture. Measure the maximum temperature of the mixture. Repeat steps 1 to 5 with different masses of magnesium powder. And our first question is, give 2 control variables the student should use. So I need to know what a control variable is. So a control variable is some of the things in the experiment that I keep the same to make it fair. So that's the background knowledge I need to answer this question. So then I've go, well, what are they keeping the same? Well, they're going to be using different masses of magnesium powder, so it's not that. They're going to be measuring the maximum temperature. That's probably going to change. That's why they're measuring it. So it's not that. Stir the mixture. We know they're changing the amount of magnesium powder. Measure the initial temperature of the copper sulfate solution. That's something they should probably keep the same. So initial temperature. Now I'm being specific and saying initial temperature because we don't want them to think we mean maximum temperature, which we've just said might change. Keep going. Add copper sulfate solution. Well, I said how much. Well, they should keep that the same as well. So volume of copper sulfate solution. So notice I got my answers by reading back over the method. I didn't just pick them out of my head. All of this information's there to help me. Now the next question, suggest one change to improve the accuracy of the investigation. Now there's loads of answers you could put. I'm going to go for a very specific one I want you all to remember though. To improve any investigation, if the person's not already doing it, the way to improve it is always repeat readings. Now, putting repeat readings on its own will not get you a mark. It's not enough. You've got to say what you would do with the repeat readings. So, and calculate a mean. You can never just put do repeat readings. It's got to be do repeat readings and calculate a mean. Now, other answers you could have for this. Now, it did tell me to only put one. So in the exam, I would only put one. But it is an experiment to do with temperature. It is an experiment to do with warming something up. So any way of me insulating that beaker would actually help to keep the heat in. That's specific to this experiment though, whereas the answer I've put will work on any experiment where they ask us to improve the accuracy if they're not already doing repeat readings. Now we then move on. The table below shows the students' results. Explain the conclusions that can be made from the trends shown in the results. Use data from the table in your answer. Now that use data from the table is an instruction. I must use data from the table if I'm going to get full marks on this question. If I don't, I've not followed their instruction, so I've not completed the question. Now, this is a 6-mark question, so I want to put as much as I can. Now, I'm going to write further up here just so you can still see the table of results, but you would obviously write your answer on the lines provided. Now, if I'm going to explain the trends, I need to say what the trends are. And there's 2 things I can see in this table of results. Well, the mass of magnesium just goes up in 0.1s all the way down. As it does, the temperature increases, but then it stops increasing. So there's 2 parts of this table already. So the first thing I'm going to say is, initially, as the mass of magnesium increases, if I can spell, temperature increase also goes up. Yeah, because as this is going up, these numbers are going up as well. Now, I've just described everything up to there because that's where it keeps going up. It doesn't keep going up after this bit. So, and it did say use data from the table. So initially, as the mass of magnesium increases, the temperature increase also goes up between 0.1 and 0.7 grams. I've now used data from the table. But now I'm going to explain this bottom bit. So after 0.7 grams, the temperature increase stays the same. Again, I've used data from the table. I've said when it starts staying the same. But this is a 6-mark question. I need to put more. I've probably got about 1, 2, maybe 3 marks out of what I've written so far. But there's more I can say. It did say explain. But there's one other thing I'm ignoring at the moment. I said after 0.7 grams, the temperature increase stays the same, but that's not the same. I think that that's an error in the experiment. I think that that's an anomaly. So at 0.9 grams, there is an anomaly. So I've noticed it. I'll get credit for that. Which is higher than the results before and after it. So now I've gone down this, I've looked at what are the trends, I've used data in the table, I've said between 0.1 and 0.7 grams, what happens after 0.7 grams, I've said there's an anomaly at 0.9 grams, I've said how I know it's an anomaly. So I'm racking up the marks here constantly, but there's still more I can say. I mean, I can add more detail to this bit, really. I've just said initially as the mass of magnesium increases, the temperature increases. But if you look, I can be more specific. As the mass of magnesium goes up by 0.1, the temperature goes up by 3. And that keeps happening, goes up by 0.1, goes up by 3. So, I'll go down here now to make myself some more space. As the mass of magnesium increases by 0.1 grams, the temperature increase goes up by 3 degrees C. Now, really, if I was being good at this, that bit should really go with that top bit there. Now, if I'd done that in the exam, I'd probably maybe label things. I might do a little arrow saying, read this bit next, sort of thing to the examiner. It wouldn't matter too much, but it probably that's the way it should have been. But again, that's more I'm saying. Now, a final bit I can say is, well, I actually can work out why it stops going up. Although I'm adding more and more magnesium, I'm not adding more and more of the chemical that it was reacting with. If I just scroll back up quickly, the magnesium was reacting with copper sulfate solution. Well, I'm not adding more of that. When that runs out, nothing's going to happen. So this must be where the copper sulfate solution had all reacted, and there was none left to react with any more magnesium. So the final point I'm going to make, which I'll have to make up here to try and keep everything on the screen, is the temperature stops increasing at 0.7 grams of magnesium because all of the copper sulfate has reacted. Now, obviously, if you were doing this question, it would look a lot neater because you'd have done it on the lines. But think about the amount I've just said about one table of results. So that's what you're trying to do if you are asked to explain conclusions and describe trends in a table of results. Look, does it go up? Does it go down? Does it go up the whole time, or does it stop and stay the same? Or does it go up and then down? Describe each part to make sure you're getting all of the marks. And if it says use data from the table in your answer, make sure you use data from the table in your answer because it is an instruction and you must follow all instructions. So I hope that helped.